Welcome to this Executive Masterclass, Focused Learners. Today, I'm stepping into the role of your managing director to walk you through what is essentially a massive, high-tariff client brief, Cambridge AS and A-Level Mathematics, 9709. We're running a deep dive audit on Section 4.1, Forces and Equilibrium, and we're zeroing in on friction and limiting equilibrium, or F equals mu r. You can really look at this explainer as your corporate training playbook. We are going to build up your analytical framework from scratch so you can structure your exam responses with the absolute clarity and authority of a senior executive consultant. Let's get to work. Okay, let's dive right into this because this quote is just wow. This is pulled straight from the Cambridge Principal Examiner reports, and they explicitly state that this is one of the most misunderstood areas in the entire syllabus. The anxiety around this specific topic is completely palpable, right? The failure rate on these multi-part questions can be frankly staggering. But we are going to fix that today. We're not just solving a math problem here. We're diagnosing exactly what our ultimate stakeholders, the examiners, are actively looking for and pinpointing exactly where most candidates lose their footing. Here is our strategic agenda for today's briefing. We'll kick off with the friction trap, move into theoretical foundations, outline our procedural framework, figure out how to lock down those winning method marks, highlight the top examiner warnings, and wrap up with critical exam strategy. Let's move. Segment 1, the friction trap. So why do so many candidates struggle with multi-stage analysis in mechanics? Well, think of typical students as two junior consultants on our team. You've got consultant Alex. Alex is great with data points, can calculate that normal reaction R flawlessly, but completely drops the ball on the final proof. No executive summary delivery whatsoever. Then you have consultant Sam. Sam writes these incredibly persuasive conclusions but lacks the rigorous physical case study backing, totally failing to actually resolve forces parallel to the plane. Both of them fall right into the friction trap because they're missing the link between knowledge, application, and analysis. In a multi-stage problem, if you drop your structured application, you are basically hemorrhaging method marks. You absolutely have to prove your work at every single step. Moving on to segment 2, theoretical foundations. Listen, to meet these top-tier academic benchmarks, you have to demonstrate logical, structured reasoning. And this slide brilliantly illustrates exactly what I mean by foundational compliance. Limiting equilibrium isn't just some throwaway phrase. It is the precise mathematical state where static friction is at its absolute maximum. F exactly equals mu times r. It's that critical tipping point right before motion actually occurs. The very best candidates, they always lock down this precise terminology and this theoretical state before they even think about throwing numbers into an equation. And the principal examiner reports highlight a massive competitive advantage right here. Candidates who integrate cross-topic connections, like connecting friction to kinematics or resolving forces on an inclined plane, they achieve significantly higher marks. It's all about showing the examiner that you see the entire interconnected mathematical ecosystem, not just isolated standalone equations. Segment 3, the procedural framework. Now, what's really fascinating about this slide is this 5-step standardized sequence. Think of this as your operational matrix. First, deconstruct the question. Second, extract the relevant data directly from those texts and diagrams. Third, select your analytical framework. Fourth, execute your analysis with crystal clear notation. And fifth, verify and present your results. Actually, before we jump into exactly how this sequence wins you those crucial marks, I need to pause the slide deck for a quick mid-masterclass mandate. To ensure your academic portfolio remains highly competitive, you need to subscribe to our channel Ace the Exams at the handle @AceTheExams and enable notifications for our weekly consulting insights. We provide this executive edge directly to you. All right, let's resume the briefing. Segment 4, winning method marks. Let's run a quick live diagnostic, comparing a really weak approach to a top-tier one. Superficial breadth is basically just dumping unformatted numbers onto a page without explaining any of the syntax. Analytical depth, on the other hand, means showing the examiner exactly why you're doing what you're doing. For instance, analytical depth is explicitly demonstrating why you're using an inequality, like F is less than or equal to mu r, for static states, rather than just forcing an equals sign because you memorized a single formula. You have to justify your decisions with hard mathematical evidence. Segment 5. Top 3 examiner warnings. Let's look behind the curtain. All right, I want to do a live audit workshop with you right now. Imagine a 60-second visual timer ticking down on the boardroom wall. You are auditing a past paper response. Where do you think the highest value insights are lost? Where exactly does the analytical framework completely collapse? Let's reveal the top 3 risk assessment failures extracted straight from Cambridge's own data. Number 1. Confusing mass and weight when calculating the normal reaction. Honestly, this is a fatal error right out of the gate. Number 2. Assuming a system is in limiting equilibrium when it's actually accelerating, just a complete misread of the context. And number 3. Poor presentation of resolved force vectors. Look, practical application requires you to audit your own performance as you write. If your directional vectors aren't visually crystal clear, you are literally just leaving points on the table. So, the absolutely crucial point is right here on this slide. This is a direct red-level examiner alert. Candidates consistently fail to state their directional assumptions. Your authoritative coaching correction for today is this. Always clearly state your directional assumptions before calculating. Don't just assume the examiner magically knows which way you are resolving your forces, whether you're resolving vertically or taking moments about a point. Explicitly map it out on the page. Final segment, critical exam strategy. Let's take a look at this matrix. To truly excel, your problem solving has to use a structured evaluate framework. When you're assessing the quality of your evidence, you must note any theoretical assumptions that have been made in the model. For instance, in mechanics, this means explicitly recognizing when you are treating a block as a quote-unquote particle or when you're assuming a light inextensible string. Interpreting these constraints is exactly what transforms a basic standard calculation into a top-tier executive-level mathematical argument. Now, to ensure you can deploy this entire framework perfectly under the intense pressure of the exam hall, I've created a strategic memory hack for you. DESEP. Deconstruct the question, extract the data, select your analytical framework, execute the analysis clearly, present your findings with context-specific terminology. If you commit this acronym to memory, I promise you, you will never face that blank page panic again. I want to leave you with this provocative final thought so you can audit your own performance going forward. Are your mechanics answers simply reaching a number, or are they actually proving a structured, evidence-based conclusion? Because frankly, that is the exact difference between merely passing and totally mastering the subject. Your action items are clear. Practice past papers and apply this exact executive framework we built today. Now let's officially close this deal. I need you to subscribe to Ace the Exams at the handle @AceTheExams, hit that notification bell so you never miss a briefing, and drop a comment down below right now with your current level and your target subject. Class dismissed.